So I'm going to do part 2 of section 4.4. And the beginning of this, problems 25 through 34, want us to find an equation of a tangent line. And in order to find an equation of a tangent line, you need a point and you need a slope of a tangent line. Well, nicely, I'm giving you the point, but I don't have a slope. And in order to get the slope, I have to find the derivative and plug the point into my derivative. So for 26, eventually I'm going to go y minus y1 equals m times x minus x1. And to do this, I need a point and a slope. I have the point, so I already know it's going to be y minus 1 equals m times x minus 2. I just don't have the slope. So the beginning of the problem, the fact that it gives me a point, it gives me most of what I need to find an equation for a line. Because to find an equation of a line tangent to a graph, you need a point and you need the slope of the line at that point. And you get the slope of a tangent line by plugging the coordinates of the given point into the derivative. So before I finish this up, I need to get a slope. In order to get a slope, you take a derivative. The derivative of this function, the derivative of x cubed, is 3x squared. The derivative of y cubed is 3y squared. But because I took the derivative with respect to x of a term that had a y, I tack on a dy dx. And the derivative of 9 is 0. And the point has nothing to do with the derivative. I need to solve this for dy dx. So I'm going to get 3y squared dy dx equals negative 3x squared. That's just subtracting 3x squared from both sides. And now I'm going to divide both sides by 3y squared. The 3's are going to cancel, but I'm still going to be left with a negative. So I'm going to get dy dx equals, I'm going to put a negative 1 here so I don't mess up. Dy dx equals negative 1x squared over y squared. So I have now a formula that gives me slopes of tangent lines. How do I get the slope of my tangent line? I just take the points and plug them in. So I'm going to go, my slope is going to equal negative 1 times x squared, which is 2 squared, over y squared, which is 1 squared. I'm just taking the values 2 and 1, plugging them for x and y in my derivative. So this is going to be negative 1 times 4 over 1. That's negative 4 over 1, which is negative 4. So the slope of my line is negative 4. So this is a little bit new because I have to use implicit differentiation to find the derivative. And when I'm finding the slope of the tangent line, I have to put both an x and a y in as opposed to just an x like we did earlier in the semester. So to finish up problem 26, y minus y1, which is y minus 1, equals negative 4, which is m, times x minus x1, which is x minus 2. I get y minus 1 equals negative 4x plus 8. And then I add 1 to both sides. And that's going to give me my answer. The equation of the tangent line to the function that I started with at the point that I started with is y equals negative 4x plus 9. So you should be able to do something similar for problem 25. I'll move on to do 28. Alright, so I need the derivative before I can get a slope. So my first step in any of my problems is going to be to find the derivative, because if I'm finding the equation of a tangent line, I need a slope. To get the slope, I need a derivative. So the derivative of 2x cubed is 6x squared. The derivative of 3y squared is 6y, but I'm taking the derivative with respect to x, and the term had a y. So I tack on a dy dx. And on the right side, the derivative of 57, because it doesn't have an x, is 0. Now I'm going to solve this for dy dx. I'm going to minus 6x squared from both sides. When I do that, I get 6y dy dx equals minus 6x squared. Now I'm going to divide both sides by 6y. and I'm going to have my derivative, my dy dx. And it's real similar to the last derivative. I'm going to cancel the 6's. I'm going to leave a negative 1. So the derivative is negative 1 over x squared, negative 1x squared over y. So the slope of the tangent line, is going to be m equals negative 1, and then in for the x, I'm going to plug a 3, and in for the y, I'm going to plug a 1. So this is going to be negative 1 times 9 over 1, which is going to be negative 9. So what the derivative gives me the ability to find the slope of a tangent line. So my slope is negative 9, my point is 3, 1, and now I'm just going to go y minus y1 equals m times x minus x1 to get my answer, because I'm asked to find an equation of a tangent line, so I should find a line. So y minus 1 equals negative 9 times x minus 3. This gives me y minus 1 equals negative 9x plus 27. And then I'm going to add 1 to both sides and get my answer. So my answer for problem 28, the equation of the tangent line at the given point, is y equals negative 9x plus 28. We never factor on lines. We leave it in the y equals mx plus b form. So give 27 a go. Should be a lot like my 28. Alright, so this is a cut and paste work for problem 30. I messed up the first time I did it, so let me try to do a better job this time. So for problem 30, we're given a point and an equation that we want to find the equation of a tangent line to, our function that we want to find the equation of the tangent line to. Of course, I know I'm going to use the formula y minus y1 equals m times x minus x1. And I know for x1, I'm going to plug in 8, and then for y1, I'm going to plug 2. So without even doing any calculus, I know that my equation is going to be y minus 2 equals m times x minus 8. That's just simply replacing the first point, the x coordinate of the first point for x1, the y coordinate of the first point for y1. What I need to be able to do is replace the m with the correct m. And in order to do that, I have to find the derivative with respect to x. So I'm going to do the derivative. The derivative of 3y squared, I go 3 times 3 is 9, lower the exponent by 1, and tack on a dy dx because I took the derivative of a y. For the x, the cube root of x, to take the derivative of it, I have to think of it as x to the 1/3 power before I make the attempt at my derivative of it. And so to take the derivative of cube root of x, I rewrite it as x to the 1/3 power. I bring the 1/3 out front and get a 1/3 x, and I lower the exponent by 1. And in terms of lowering the exponent by 1, I'm going to lower it by 3/3, and the exponent's going to become negative 2/3. And then to the right of the equal sign, the 26 doesn't have a letter, so it has a derivative of 0. And the point has nothing to do with the derivative, so I'm going to just ignore that and just move on from what I have here. Probably could clean this up a little bit by moving the negative exponent with the x down to the denominator. The original problem had a radical. It isn't super important that my answer for my derivative have a radical if I know how to use fraction exponents on my calculator when I go to find the slope. Ultimately, I'm going to plug in 8 for x and 2 for y into the derivative. If I'm comfortable plugging my number into a derivative with a fraction exponent, I don't need to change the fraction exponent to a radical. When all I'm doing is using the derivative as a tool to find a slope, I don't have to have the most simplified form of the derivative. So let me try to get this solved for dy dx by minusing 1 over 3x to the 2/3 power from both sides. And when I do that, on the left side, I'm going to write it up here because I'm kind of out of room. On the left side, I have 9y squared times dy dx. And on the right side, 0 minus anything is that thing that I'm subtracting. So I'm going to get minus 1 over 3x to the 2/3. The next thing that I should do is I should divide both sides by 9y squared, because that's the number in front of the dy dx. That turns out to be a disaster if I do that. This is part of the reason I'm re-recording the video, because when I divide it by 9y squared, on this side I had a -1 over 3x to the 2/3 over 9y squared, and I just couldn't enter that in my calculator well. But dividing by 9y squared will be the same as multiplying by its reciprocal. It's going to be the same as multiplying both sides by 1 over 9y squared. So on this step right here, in my efforts to solve for dy dx, instead of dividing by 9y squared, I'm going to multiply both sides by 1 over 9y squared. And that's going to make, when I get to my calculator, the math a lot easier to do. On the left side, when I multiply by 1 over 9y squared, the 9y squareds cancel, it leaves me with 1 times dy dx, which is dy dx. And on the right side, the numerators are a -1 times a +1, which is a -1. In the denominators, I'm going to multiply the 3 and the 9 and get a 27. And I'm just going to leave the letters in order, alphabetical order, with their exponents. So I'm going to have an x to the 2/3 and a y to the 2nd. So my derivative is -1 over 27x to the 2/3 y to the 2nd. I need to get a slope to finish up my answer. And to find the slope, I'm just going to take the values of x and y given and plug them into the derivative. So my slope is going to be m equals -1 over 27 times 8 to the 2/3 times y squared, which is times 2 squared. So let me try to enter that on my calculator. That's still not going to be that fun. On my calculator, I'm going to have to put the entire denominator in a parentheses. So when I go to do this on my calculator, turn it on, clear anything out that's in there, I go -1 divided by, and then parentheses 27, and then times 8 to the 2/3. For the 8 to the 2/3, I don't think the 8 absolutely has to be in a parentheses like I have it, but I can put it in a parentheses. But the exponent 2/3, 2 divided by 3, has to be in a parentheses. So that 8, whether I put it in a parentheses or not, wouldn't have been a deal breaker in terms of getting the right denominator. But that 2/3 had to be in a parentheses because the exponent's a fraction and it needs to be in a parentheses. I need one more times. It's going to be times 2 squared. And if I wanted to, I could have just said times 4. And I'm almost done. I've entered everything in the denominator properly, and I have to close out the parentheses that I started. I started my denominator with a parentheses. I have every parentheses closed except that one. I'm going to close that parentheses, and I'm going to hit enter. And now I'm going to hit math enter, enter to make that into a fraction. So my slope that I'm trying to find to finish up this problem is -1 over 432. So what I'm going to do now is take that value and plug it into my shell of an equation. So I'm going to get y minus 2 equals -1 over 432 times x minus 8. The right side is going to be a bit of a pain to reduce. The left side, temporarily, I'm going to leave as y minus 2. And on the right side, the first multiplication is easy. -1 over 432 times x, I'm just going to write as -1 over 432x. But -1 over 432 times -8 is a nuisance to do, so I'm going to pull out my calculator. And on my calculator, I'm going to do that. I'm going to do -1 over 432 and put it in a parentheses just to be safe. And then times with a parentheses -8. So that's this -1 over 432 times that -8. Gives me an ugly decimal. I math, enter it. And that's going to give me a +1 over 54. When I multiply two negatives, I get a positive. Not quite done. To finish this problem up, I'm going to add 2 to both sides. And this is going to take me to the answer, because on the left side, I'm going to have the y solved for, and that's my goal for all these, find an equation of a line. On the right side, The negative 1 over 432x is just going to hang out and not change. And then to add 2 plus 1 over 54, I'm going to do my calculators for that. I'm going to go 1 divided by 54 plus 2 and do math enter, enter. And I'm going to get plus 109 over 54. I think that's perfect. So that's grungy. Unfortunately, in calculus, there's just a certain amount of grunge you just have to deal with. I took my calculator, I used my calculator to handle a lot of the grunge here. So hopefully this was reasonably followable. You need to try to duplicate what I did for problem 29. Your answer is going to probably be similarly ugly. So 31 and 32 will be the last ones in this grouping that we're going to do. So let me jump into 32. The derivative of y cubed is 3y squared. I took the derivative of a term that had a letter y with respect to x. I tack on a dy dx. The derivative of minus 7y is 7. I took the derivative of a term that has a y with respect to x, so I tack on a dy dx. To the right side, the derivative of 40 is 0. The derivative of minus 2x is minus 2. I'm going to factor out a dy dx on the left side. I'll be left with 3y squared minus 7. And I need to divide by the 3y squared minus 7. Wow. My derivative doesn't have an x in it. That's okay. So I'm going to get dy dx equals minus 2 over 3y squared minus 7. And I will need to find the slope. Well, the point that I'm given here is the point 2, 4. And I want to plug 2 in for x and 4 in for y. There's no x to plug the 2 in, but I do need to plug 4 in for y. So my slope of the tangent line, m, is going to equal negative 2 over 3 times 4 squared minus 7. That's negative 2 over 3 times 16, which is 48 minus 7, which is negative 2 over 41. I was afraid to use my calculator. So now I have a point and a slope. So I'm going to use my point of 2, 4 and my slope of negative 2 over 41 and go y minus y1. Y minus 4 equals negative 2 over 41 times x minus 2. On the left side, I'm going to leave it y minus 4. On the right side, the first multiplication is easy. I get negative 2 over 41 times x. This next multiplication, I just multiply the negative 2 and the negative 2 and get plus 4 over 41. And now to finish this up, I have to add 4 to both sides. On the left side, I'm going to get my y that I need to have. So on the left side, I'm going to have y. I'm also going to have this minus 2 over 41 x. And then I'm going to add 4 and 4 over 41 plus 4, math, enter, enter on my calculator and get 168 over 41. So there's my answer to problem 32. A little bit nasty, but in calculus you just got to get some grunge. You just can't avoid it. So do 31. I'm voting for both of us to just skip these. I know I wouldn't put a problem this nasty on the test, and just skip that and do it if you really want to. But boy, that looks like it's going to be a mess. So we have one set of problems left, and this set of problems is going to connect this section 4.4 to the word problems we do in section 4.5. And so far, every problem that we've done dy dx. We've taken the derivative of every term with respect to x. In problems 35 through 42, we're taking the derivative of r with respect to t, and there's not even a t in the problem, but I can still do this. So, and how do I do it? Well, just the same way. I use implicit differentiation. So anytime I take a derivative with respect to t, I need to emphasize that I'm taking a derivative with respect to t. So the derivative of a is hardly any different than the derivative of x. The derivative of x is just 1, the derivative of a is just 1. And when I'm using implicit differentiation, I multiply by a fraction. In the numerator, I put a d with the letter that the term had. And in the denominator, I put what I'm taking the derivative with respect to. Generally, it's with respect to x, but in this problem, it's with respect to t. So the left side of this, when I take my derivative, is just 1 dA dt. Now on the right side, I'm going to take my derivative. This pi is just a number, so I'm going to bring the 2 and multiply it by pi. I don't need to use the product rule because that's not a variable. I'm going to lower the exponent on the r to 1. And I'm using implicit differentiation. The term that I took the derivative with had an r, so I add a dr in the numerator. And in the denominator, I write the letter that I'm taking the derivative in terms of, which is dt. This problem says determine dr dt, so I need to solve for dr dt. The left side, I'm going to just write it as dA dt. The right side is 2 pi r times dr dt. And my goal is to find out what dr dt is. Well, there's something multiplied by dr dt. I need to divide both sides by it to get what dr dt equals. And so on the left-hand side, I'm going to leave this nasty dA dt over 2 pi r equals dr dt. And that's going to be my answer to problem 36. That is what dr dt is. Even though the original problem didn't have a t, I can still take a derivative with respect to any letter that I want to take the derivative with respect to. So give 35 a try. It's not quite as hard as mine, but it's real similar. So in each of these problems, we're finding dr dt, so I need to take the derivative with respect to t. For problem 38, the derivative of v is just like a derivative of x. It would be 1. Then I tack on the letter the term had that I took the derivative of was v, and I'm taking the derivative with respect to t. To the right side of the equal sign, the derivative of 2r squared would generally be 4r, and what I tack on is the term had a letter r, that's the dr in the numerator, and I'm taking the derivative with respect to t, that goes in the denominator. The derivative of 8, because it's a constant, is 0. So what I have is dv dt equals 4r dr dt. The instructions said solve for dr dt, so I'm going to solve for dr dt by dividing both sides by 4r. On the right side, the 4r's are going to cancel, and I'm going to get the dr dt solved for. On the left side, I have dv dt over 4r. And that's the answer to problem 38, because all my instructions were to find dr dt, and so I found it, and it's not a very nice answer, but it's the answer that I need to have. This kind of finding the dt's, they come up in the next section, so I thought we'd just be exposed to them now. Just a few more problems to do, specifically 2 more problems to do. So let me do it, dr dt. So the derivative of r would be 1, but I took the derivative, the term had an r, so I'd need a dr. I'm taking with a derivative with respect to t, so I get a dt. The derivative of 12x would generally be 12, but the term had a letter x, and I'm taking the derivative with respect to t, so I need a dx dt. And the derivative of 10 is 0. So that's gone. This is lovely because the left side now is dr dt. The right side is 12 dx dt. I'm done. Because my goal was to find dr dt, and it's already solved for. Because the r was already solved for, this was an easy one to do. All right, 1 more problem for me, maybe 2 for you. 42. Take the derivative of r, which would be 1, but I'm taking the derivative with respect to t. So in the numerator, I put a d with the letter I started with. In the denominator, I get with respect to t. The derivative of 5y squared would be 10y. I multiply by a fraction. The term had a y in it, so I get a dy in the numerator. I'm taking the derivative with respect to t, so I get a dt in the denominator. The derivative of plus 6 is 0, so I'm done again, because the left side simplifies dr to the dr dt. That's what I'm solving for. And the right side is 10y times dy dt. And that's all there was for that group of problems. So that was kind of a nice, refreshing end to this section. And the next section, although it's word problems, I think is way easier than this section. All right, so finish 41, and we're almost done with this chapter.